Hi everyone, this is Howard. Welcome to another Star Talk Tuesday, this Tuesday being July 7th, 2020. Now, what I've done is I've accelerated the day. I've advanced to the 9th. That'll be Thursday. Now, there's a reason for this. Is because the moon moves itself into a different position in the sky. It's arriving up a little bit later. You could certainly see what we're talking about today. You could see it tonight. It's just that you get perhaps a better view with the moon a little bit further away from this particular segment of the sky. So let's go ahead and accelerate into the evening. So we're going to go ahead and move that clock forward, and again, always try not to go too fast. Somewhere right about there. As we look, of course, we look to the west as the sun sets. We love to look at the west when the sun sets here in Florida. And there our stars come into view. Now, clearly what we don't see in the western sky anymore is any really bright objects. We see the constellation of Leo here with the sickle constellation, or excuse me, sickle asterism there. We'll just put up the lines. There we go. There's that sort of backward question mark. There's Leo getting ready to set. And up here we have Arcturus, which is our guide to our next place, which is the spot that is, ironically, you'd think it would be the best place, but when something is directly overhead, it can be problematic to observe, especially if you're an observer with a refractor. It can potentially be a problem. And binoculars, if you're using a tripod, because what you can't do with binoculars on a tripod is point the binoculars straight up at the sky, because clearly the tripod will be in the way. So this is a very advantageous time to utilize the blanket on the grass method, where you can hold the binoculars in your hands and look up at the sky and look at this little curving group of stars. Now, this is what I mean by, in planetarium shows, I get a lot of people that will ask about, what's this little group of stars up here? And this group up here, we're going to go ahead and put the artwork up so you can see it. That is the crown. That is Corona Borealis, the crown of the north. We'll put the labels up. There we go. Not those labels. Those labels. There we go. Corona Borealis. And then just to point out, of course, down here in the southern sky we have Corona Australis. So what we're looking at is crown of the north, crown of the south. One looks like a laurel wreath, and of course then the other one up here in the north looks more like a traditional sort of, I'm a king and I'm going to wear this kind of a crown. Anyway, Corona Borealis is this place of interest that I want to mention tonight because it's got a fascinating little phenomenon going on here that I just learned about. So let's get rid of that artwork again, and we're going to zoom in. See, I'm looking into a part of the sky. Actually, I'll bring it out just so you can see where it is. It is darn near, almost at the center of this sort of circular representation of the sky, meaning if you were laying down on a blanket looking due south, the objects rise out of the east and set in the west. You could see Corona Borealis is almost right there at the zenith of the sky. So this would be an excellent time to just lay down and look into this little group. Now, as I try to wheel the view, it rotates the view. I apologize for this disruptive motion, but as we move in, it'll be a little bit easier to control. And so I want to point out something. Over here, we get the shape of that crown. Then we get to this star right here. And that star is known as Epsilon Coronae Borealis. So it's one of the brighter stars, certainly part that you can see with the naked eye. But as we get a little bit closer, there's a tiny little star here I want to mention here. I practiced this before, of course. I started this because it was kind of hard to find, but I know it's this one right here, that one. And as you can see by the name, it's called the Blaze Star, otherwise known as T Coronae Borealis. Now, this little unassuming star is barely visible, but it's called the Blaze Star. And when a star gets a moniker like that, it's because they've done something pretty cool to earn it. So the Blaze Star is a fascinating star. It's actually a binary system in that there is a red giant star that is sharing a sort of an orbit with a white dwarf companion. Now, this white dwarf companion is sort of the hot component. It's the core of a star that's like our sun, that's already expired and crushed its core down into a solid, dense sort of blob of, I don't say a blob, it's about the size of planet Earth. It's crushed. Imagine the mass of the sun squeezed down into a core-shaped object roughly the size of planet Earth, and it's carbon. And it's squeezed down to the point where the electrons have been squeezed down to their bare minimum orbits around their nuclei. They can't be squeezed any further. So it's like you've taken something that's on springs and squeezed down the springs until the point you've compressed them as far as they can go. So you can't go any further. And so these carbon atoms have been squeezed down as far as they can go, and they got this tight, just incredibly massive object called a white dwarf. And it radiates lots of energy and light that typically radiates the ejecta that comes out from the star when it dies. So this happened a long time ago, and now what you're left with is this glowing white ember, this thing called a white dwarf, orbiting this red giant star. Now the distance between this is pretty astounding. The red giant star sits about half an AU, meaning an AU is an astronomical unit, the distance between the Earth and the Sun, 93 million miles. So the distance between these two stars, or the white dwarf and the red giant, is half an AU, meaning somewhere in the neighborhood of the orbit of Venus, that distance between the Sun and Venus. That's how far apart these two objects are. It takes about 228 days for them to sort of orbit around each other. And as that happens, the white dwarf is pulling material, hydrogen, down onto the white dwarf. And so what happens is, on this dense core of carbon, hydrogen is building up, layer upon layer upon layer, collecting like a ball of yarn, building up. And eventually there's so much pressure downward on top of the very first layer of hydrogen that the pressure triggers a fusion reaction that quickly vaporizes and just, I'm going to use the term incinerate, but that's more of a chemical reaction. But just basically, there's a runaway effect, and there's this titanic explosion that doesn't destroy the white dwarf. It just vaporizes the hydrogen, and it's what's called a nova. And what happens is, what is typically a dim star suddenly brightens over a period of perhaps days, and sometimes in some cases nova brighten for years. The reason why this is called a blaze star is because it was first observed at its brightest point when it became a very bright object, the nova, in 1866. It happened again 80 years later in 1946. And now, if you follow the 80-year method, it will happen again in the year 2026. Now you might say, well, that's a few years off, Howard. What's interesting to note is that there was a very consistent level of brightening in the output of the star that occurred just a few years before the outburst in 1946. Well, we had a similar increased level of brightness back in 2018. And that leads astronomers to conclude that we might be near another burst of the blaze star. So as you look up here to the crown, of course looking at the crown is itself an interesting thing, but there's this tiny little star, and it will brighten up to about magnitude 2. Now, if you don't know what that means, you might think that sounds impressive. Let me explain it this way. This star right here, Epsilon Coronae Borealis, is magnitude, where are we? Let's look at its magnitude. Its absolute magnitude is 0.06, so it's really bright. Oh, excuse me, magnitude 4.10. There we go. So it would be a little bit brighter, about half as or twice as bright as that. So not enormously bright. So you would be looking up there and you'd see this brightened object. Now, you might ask, what value is there in this? If I could use a metaphor, perhaps you might be able to compare it to and see some sense of value in this. Imagine that you have a very large yard, perhaps 10 to 20 acres of just space, lots of grass, and somewhere in your yard is a very tiny little flower, so small that you need a magnifying glass to see it. But it will bloom only one day every 80 years. And it does this beautiful thing and looks very pretty, but you have to get very close to it and look at it with a magnifying glass. If you think it's worth your while to look at something like that, then it might be worth your while to pay attention to the crown of the north, because you might catch a moment where you see a tiny little flower blossom in that constellation that hasn't done so, well, in almost 80 years. So like the astronomers are saying, we're due. Now, that's a very interesting reason to look in the crown. Now, we got some other things, of course. We've got Hercules here. It's pretty much nestled right in between Boötes, the herdsman, and Hercules. Of course, Hercules doesn't need any introduction, but we'll put the artwork up there so you can see how the sky is defined definitely by Greek mythology here. Now, as we pull back out, we're going to drag our view to the south, because what we see coming up, of course, are the planets. Now, we'll get rid of the artwork and make our time go by. Look at all those satellites moving through the view. And as we get to, I know this is going to be late, but we're going to push this to right around 3 o'clock in the morning. Because then we've moved into July 10th, and here comes the moon. And of course, trailing not too far behind it is Mars. So we get this to right around 3 o'clock in the morning. There we go. We're just about 10 minutes after 3. So as we get over into this part of our sky, we get this beautiful view of, well, there's that bright glowing moon. It looks full, but it's not. It's actually a waning gibbous phase rising up late like this. We're very soon to be at the last quarter. But what's nearby, it should pop into view. Now, the moon itself, of course, is an interesting thing, but I don't want to draw attention to that, because right up here, there it is. I had to find it. It's Neptune. So not far away from the moon. The moon is just south of it. Now, normally, from relatively dark skies, you can actually spy Neptune in a pair of binoculars. Now, it won't be that interesting, but you can detect the slight blue hue of Neptune. But in a telescope, you'd need a fairly large aperture to be able to get any sort of resolution on it. But from my backyard, I can get a view. Here, let's lock that in so it doesn't move away from us. There we go. And we're right about there. I get this just an observable disk with this faint sense of blue to it. Kind of darkish, because Uranus has another blue color, but it's definitely decidedly lighter in blue. Neptune is not quite as dark as you see in the images, but it's definitely darker than Uranus. Anyway, so Neptune is up in the sky now, rising up early enough that you can catch a view of it, and it's got an interesting marker nearby, the moon. Now, of course, as we get farther out, you can see how challenging it is to see that. You've got Mars, and now Mars is definitely, its showtime will be coming in October. There's nothing wrong with taking a sneak peek now. And as we see Mars coming up, it's not quite at opposition yet. That will happen in October, and then we'll see a fully illuminated Martian disk. Now, as we look here, the south polar cap is very small. It's very tiny here. But in reality, and we were just observing this, we were imaging it just a few weeks ago. The polar cap is actually about that big right now. It's very large. But by the time October rolls around, it will have shrunk. It will have melted or evaporated, so to speak, and it will be a lot smaller than it is currently right now. Now, this cycle, of course, happens as Mars continues to move around the Sun. So changes constantly occur, and we'll go back to its normal, or I should say normal, but what we see right now, as large as it is, it will return to that at some point. Now, as we pull back out, of course, this is right before the morning hours. 3 o'clock in the morning, you're probably asking yourself, why the heck did I listen to the sky to get up so early? It's cloudy. I can't see anything. And that's always the risk that we run when we want to look at the sky. But anyway, I've probably run out of time. Everyone, thanks again for joining us. We'll catch you next time.